Hello everyone, I'm Pratik Kasbe. I'm a PhD candidate at the University of Akron, and today I'll be discussing a topic which is a promising solid lubricant based on 2D iron oxide and reduced graphene oxide for anti-corrosive coating applications. So the hypothesis of our experiment is based on we aim to prepare a solid lubricant coating based on graphene oxide and 2D iron oxide, which has better adhesion to metal substrate and shows high lubricity without the use of lubricating oil. So to explain each one of them one by one, the graphite derivatives are known to show high lubricity and even sometimes super lubricity, which has the coefficient of friction less than 0.01. And why is that? Is due to the lamellar structure of graphene oxide, which has the different lamellar, and when we apply the force on these lamellar, they show very low shear resistance, and that leads to very low very high lubricity. But one of the drawbacks of these coatings is the poor adhesion to various metal substrate, and we plan to eradicate that with the help of iron oxide. So iron oxide has been known as a major cause of machine failures over the decades, and it usually generates due to the presence of the humidity or the water molecules when they are in contact with the stainless steel or even iron substrate. But we aim to use this negative attribute of the iron oxide in positive way by preparing the 2D iron oxide, which has the similar lamellar structure. And what it will do is it will help in eradicating the problem which we have with graphene oxide. So combining the iron oxide, which provides better adhesion, with the graphene oxide, which has the better lubricity, we thought of preparing a coating based on the both of the materials. So we started the lubricity study by solvent casting the graphene oxide and 2D iron oxide on our silicon dioxide substrate, and we did the pin-on disc measurements at 2 Newton and 5 Newton loads. And what we observed in common was both of them showed the coefficient of friction values close to 0.2 and even less than 0.1 at higher loads. And just the pure 2D iron oxide was not feasible for the lubrication study, and it showed the coefficient of friction values much higher, close to 0.6. So next we studied the Tribo-layer tracks that were formed by the measurement of pin-on disc, and what we observed was that for the formation of a Tribo-layer took place where the ball was in contact with the substrate, and that was the expected result. But the more interesting result was the more material was used in the Tribo-layer formation in case of the 5 Newton load. So that again provided the better lubrication, which we observed from the previous slides. Next, in order to eradicate the adhesion problem of 2D graphene oxide, we did the Raman spectra after the Tribo layer formation took place. And what we observed was the poor adhesion leads to the delamination of either of the materials. And we don't want that. So we confirm that by doing the Raman spectra, and for that we observed on the Tribo layer given by the red dot both the 2D iron oxide peaks as well as the graphene oxide peaks were present, confirming the presence of both the materials. So coming back to the hypothesis, I want to conclude by saying that we successfully prepared the solid lubricant coating, which has the better adhesion, and it shows the high lubricity without the use of lubricating oils. And the mechanism driving that is due to the low shear force in the laminar structure of these 2D materials. And in future we aim to conduct these studies on various substrate, and mainly the stainless steel substrate, and to also study the surface morphology. So at the end I want to say thank you for listening to my presentation, and you can hit me up with the email if you have any questions. Thank you.